Good afternoon, class. Yes, I want to believe that you're all set for this afternoon's lesson. Um, we are continuing with the latitudes and the longitudes. That is what we started on Monday. And just a quick review, we were able to look at what latitudes are and also what longitudes are. Number two, we were also able to see how we get the angular distances of the various latitudes, and we also went a step further and looked at longitudes, again how we give them their angular references. Now the other thing that we also did was that we were able to get distances along great circles in kilometers. You remember we saying that as far as the latitudes are concerned, we only have one great circle, and that is the circle that we called the equator. But when we came now to the longitudes, we found that all the longitudes, because they are passing via the North Pole all the way to the South Pole, we called all those great circles, and we were able to get the distance along those arcs, because the concept that we were using there was the arc of a circle. And one thing that we said is that for us to be able to get that arc, then we must make sure that the radius is known. Of course, that is something that you are provided with. So today we will continue with the same, that is latitudes and longitudes. Latitudes and longitudes. So we're still in the area of distances. So let's talk about small circles today, and going by the globe that we had last time, that being the globe. Of course, here we say that we're going to have a great circle, and that is the great circle. And that great circle had a certain radius. We call that radius to the center, capital R. So small circles come as a result of us following now distances along latitudes. So I'm going to take an example here of a latitude which passes through this point here. So that latitude passes through that point, and it also has a certain radius. We're going to use a small r because we want now to differentiate between a great circle and a small circle. So that a small circle here has a radius r. Now, what will be provided with normally will be the radius here. What if this latitude we give it the latitude is passing through and the radius of the great circle is the one that gives us the angle of latitude. So in this case, if this is 40 degrees, then it automatically leads you to seeing that this angle is 40 degrees. Of course, this one. Now, the other thing that we're also going to see, according to what we discussed last, we said that these circles of latitudes are parallel. Rather, they are horizontal, all of them. So by them being horizontal, then that means that this radius here will be parallel to this other radius, because the two planes that are formed, if we were to chop, we'll get a plane here that is parallel to this other plane. So by extension, the radii are parallel. So you now see a scenario where we're dealing with a line here and another line here, and the two lines are parallel. So it follows that if this angle is 40, then this being the alternate angle, it's also 40 degrees. So there is something I want us now to develop further from there. The axis of the Earth from the North Pole right through the center of the globe all the way to the south, and this is perpendicular as such. So that is what we have. The other thing that we want to observe is the distance from the surface of the sphere all the way to the core or the center of the sphere. Again, it also gives us the radius of that distance. We need to note that. So this distance here will be R, capital R, the radius of the sphere. And we've also seen that this angle is 40 degrees. That angle is 40 degrees. So in short, now that is the triangle that we have. At this point now we want to go back to trigonometric ratios, and because here we've been given a right angle, then there were those ratios that were introduced to that were helping us relate an angle adjacent side to the hypotenuse, and also to that is the opposite side. Our interest is just the hypotenuse and also the adjacent side to this angle. So we're just going now to concentrate on two. So the ratio that we can apply here that relates the adjacent and the hypotenuse is the cosine. So we can clearly see that cosine of 40 will be given by that is now R representing the adjacent over capital R. So that is the relationship we'll get from that point. And because we want to get small r, then we make it the subject. We're going to make the subject by eliminating capital R, and in that case now we are going to multiply both sides by R. So we are going to end up with a small r is equals to capital R cos 40. Cos 40. So basically, that is how we can obtain the radius of a small circle from the radius of the great circle. Now, you need to note that now 40 here is the angle of latitude. So we'll stick to the great circle here. We'll stick to the same against latitude here, 40 degrees north. And let's take radius of this small circle will be given by r cos 40. R cos 40, where 40 is the angle of latitude. So in this case, our R is 6,370. We multiply that by 40. I want to give you a brief task to this and give me the radius. Simplify that and give me a radius in a minute. I want to believe that we have been able to obtain the R. You just need to key in 6,370, then press cos 40 degrees, then equals, you'll be able to get the radius. We are going to combine class exercises as we continue because this being a virtual interaction, I'm not able to move around and see what you're doing. So this becomes one of the tasks we expect you to give us a response on whether you are able to get the radius correctly. Good. Now, having solved the issue of radius, we want to go to distances. We want to go to distance. And we're going to use an example here to see how we get distance along great circle, small circle. Find the distance AB, I'm going to give you a reference here. A, the geographical location of A is 23 degrees north, 48 degrees east, and we also have another point B, 23 degrees north, 12 degrees west. So we want to find that distance, and as I said earlier, we'll always be given the radius of the earth. So as usual, let's take that to be 6,370 kilometers. So we want to find this distance. I want to believe that so far, even before we go to sketching the globe, we are able to visualize where the various points lie. One of the things that you're going to observe here is that these 2 points lie on the same latitude. They lie on the same latitude, but they lie on different longitudes. They lie on the same different longitudes. So in that case, we'll find that by the fact that they are lying on the same latitude, then they lie on the same small circle. Let's go to the sketch and see how the values will be like. So here we've got the globe. We've got the globe like that. Then we have a certain latitude up here. That latitude is 48 degrees to the east. And we've also got another longitude here. This longitude again, so this is again where we have our point B. That is where we have our point B. So we are now looking for this distance from point A to point B. Now, as you can see, that is a part of this circle, the one that moves around all the way, and we're just looking at this part. So the first question will be, what is the angle that this arc AB here subtends at the center of the small circle? In other words, what is the angle at the center here? So in our previous discussion, that is the angle that we called the longitude difference. From this longitude to this longitude, how many degrees are there? So longitude difference you remember in our previous points are on opposite sides, we'll add the angle. So this is to the east, this is to the west. So for us to know this angle, we'll just add 48 degrees plus 12 degrees. That will give us that will give us 60 degrees. So we angle at the center. Then the other thing that you also need to establish is the radius. So let's again go back and get the radius. So what is the radius of that small circle? From definition, we've already seen that the radius will be given by the radius of the sphere multiplied by cosine of the angle of latitude, that is 23 degrees. So that is how we are going to get the radius of this small circle here. So that small circle again, the circle is here, the radius is here, and then lastly we'll find distance AB. Do you remember, because this is now a part of the circle, in the previous discussion we are using this angle as a proportion of the entire circle, which is 360 angle. Now this becomes 60, that is this angle, divide by 360, then we multiply by the pi, which is 22/7, times, of course, this is 2, then we multiply that by the radius, which is here. So the radius is 6,370 cos 23. So again, that is the formula that you're going to use to get this distance from here to here. That is 60/360. 60/360 of pi, or rather 2 pi r. So that will be able to give us the distance. So again, that becomes our task number 2. So I expect you to give us that value. You should not be having a challenge now simplifying this using a calculator. Just fill the values in the calculator, and then we'll be able to check. In fact, I expect you now to post those values on the page so that we can